Welcome to qnawire.
This is problem number 28. So here in point H you can see a support. That support is called pinned support, and because of this type of support there will be two reactions, one vertical as well as a horizontal reaction. So let's name the vertical reaction as R of HY and the horizontal one as R of HX. Now in point G there is another type of support. You can observe that is a roller support. So because of this type of support there will be another reaction, that will be a vertical reaction, and let's name that vertical reaction as RG. Now let's draw the forces here itself. So this will be R of HY and this will be R of HX, and here this will be R of G. Now to calculate the forces in each member, first we drawn the free body diagram of this entire truss, and now let's apply the equilibrium equations. So first we have to calculate support reactions. So from symmetry, summation along h equal to 0 gives you the only thing along x axis is r of hx, so that will be equal to 0, and summation along y equal to 0, that is. Now let's take the moment at h first. So that gives us minus of rg, and the distance for its meter, plus the 48 into 4 plus 4 plus 4 plus 4, that is 16. 16 into force 48 equal to 0. So from here we can write Rg equal to 192 kilonewton. Now from along y-axis you get another equation, like summation along y gives us Rhy plus the 192, that is Rg, minus 0, that is minus Rhx, will be equal to 0, will be equal to 50. So this forces we can write Rhy will be equal to minus of 144 kilonewton. That means the direction is opposite. So here this here the direction we have given creates tension, but because there is an IT sign, so that creates compression. That's denoted by letter C, and the Rg creates compression. Rg also creates compression. Yeah. Now let's move to the next. Let's denote like the angles. the angle is, yeah, this one plus this one plus this one. Yeah, so here this will be theta 1, and yeah, this angle, let's call it as theta 1, and the angle in B, that is this one will be theta 2, and this one the that will be theta 3, and yeah, that's it. Now let's find the angles. Theta 1 will be equal to tan inverse of 4.5 divided by 12, that is 20.65. Theta 2 will be equal to tan inverse of, so theta 2 will be equal to tan inverse of 4.5 divided by 2, 4 plus 4 plus 4, so 4 plus 4, 8, so that gives us 3 by 4. So that is 36.87 degree. Yeah. Now theta 3 will be equal to tan inverse of 4.5 divided by 4, that will be equal to 48.37 degree. Yeah, 4.5 divided by 4. Yeah, and theta 2 will be equal to this 4.4 divided by 8, and theta 1 will be equal to 4.4 divided by 12. Now we found the angles. Now let's go to each joint and resolve it. First, for joint A, let's draw the diagram first. So this is FAB. There will be FAC in some slope with angle theta 1, and the 48 kilonewton. So for joint A, let's resolve along y first. Summation along y equal to 0 gives you minus of FAC sine of theta 1 minus 48 will be equal to 0. So from here the FAC will be equal to 48 divided by sine of theta 1. So we know the angle of theta 1, that is 0.65. So that gives us 136.109, that is 136.109 kilonewton. And the FAC, that is actually going outward. So as this is going outward and this is here, so Let's check it. Yeah, as FAC is going outward, and but here the in answer there will be a negative sign, so means so that means the actual direction of FAC is inward. That creates compression. Let's denote it by the letter C. The sine of theta 1, sine of 20.65, that is 48 divided by sine of 20.65 equal to my 136.109, and there is minus sign here, so this is minus of this one, so as that is minus, so the actual direction is opposite to this one, that creates compression, denoted by the letter C. Now summation along h equal to 0 gives you FAC cos of theta 1 plus FAB equal to 0. So from here we can write FAB will be equal to 128 kilonewton, and FAB is going outward from the point A, that creates tension. Let's denote it by the letter T. Now let's move to the next joint, that is joint C. So joint C, if this is joint C, there will be FCE, and just opposite to that FAC and FBC. Now let's resolve for C. Summation along h equal to 0 gives you FCE. This is along a line, so FCE equal to FAC, so that it will be 136.109 kilonewton, and here that is going outward, that creates tension. Let's denote by the letter T. Summation along y equal to 0 gives you, there is only FBC, so the value for FBC equal to 0. Now let's move to the next joint, that is joint B. For joint B, if this is joint B, there will be FBD, FAB, and the FB, so FBE, right? FBE, FBD, and FAB. The FBC is C, so you don't have to note that. So this is FBE. FBC will be here, so FBC is 0, so we don't have to consider that. Now for joint B, the summation along y equal to 0 gives you the value of FBE will be 0. Summation along h equal to 0 gives you FBD equal to FAB, so that means it's 128 kilonewton, and as it's going outward from the point B, that creates tension. Let's denote it by the letter T. Now let's move to the next joint, that is joint E. So for joint E, if this is joint E, this is joint E, this is FDE and FGE and FCE, right? So FCE, FDE, and this is FD, this is FEG. Okay, this is FD. Sorry. This is FG. Now let's solve for joint E. So for joint E, summation along H equal to 0 gives you FEG equal to FCE. So that means that is 136.109 kilonewton. So that creates compression. So the FC is going inward. That creates compression. Let's denote it by the letter C. Now, FC is here. Because of the FEG will be equal to minus of FCE. The minus of C is minus this term. So the actual direction is inward. That creates compression denoted by the letter C. Summation along y equal to 0 gives you FDE equal to 0. Now let's move to the next joint, that is joint D. Let's take it. Joint D. So if this is joint D, this is FDE, this is FBD, and this is FD, FDE, FDG. FDG, and this one is actually FDF. Now let's solve for this one. So for the joint D, summation along H equal to 0 gives you FBD equal to FDF. So that means it is 128 kilonewton, and as it is going outward, that creates tension. It's denoted by the letter T. Summation along y equal to 0 gives you FBG equal to 0. Now let's move to the next joint, that is joint F. Let's take blue. Joint F. So for joint F, if this is joint F, there will be the F H Opposite to that, there will be FDF and FFG. Now let's solve for joint F. So for joint F, the summation along h equal to 0 gives you the FH equal to minus of FDF, that is, yeah, that is opposite, so there won't be any minus, so this gives us 128 kilonewton, and this is going outward from the point F. So as it is going outward, that creates tension. Let's denote it by the letter T. Summation along y equal to 0 gives you FFG equal to 0. Now let's move to the next, and the last joint, that is joint H. So for joint H, let's draw the diagram first. So if this is joint H, there will be R of H y and F G H and F F H. So as this is joint H, let's first find the summation along H equal to 0. This gives you FGH cos of theta 3 minus 128 equal to 0. So from here, the FGH will be equal to 192.7 kilonewton, and FGH is going inward to the point H. That creates compression. Let's denote it by the letter C. So we solved the question. I hope you understood everything. Thank you.